Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Fakir Najmi bin Jalaluddin and they are my teammate.
My name is Muhammad Fidaus.
And my name is Muhammad Afiq.
And my name is Muhammad Adatikudi.
Okay, today we are about to present for Unit 1 about matrices for our assignment 2. So let's go.
Let's go.
Okay, so I will explain the types of matrices. Matrices has 6 types of matrices, which are row matrix, column matrix, square matrix, identify matrix, equal matrix, and lastly, transpose of matrix. First, row matrix. What is row matrix? Row matrix is matrix with only one row. For example, we can look at this diagram. The order is 1 by 3, which is the row have one and the column have 3. 1, 2, 4. And the second types of matrix is column matrix. Column matrix is a matrix with one column. For example, 3, 5, 1. And the order is 3 by 1, which is the row is have three row and the column only have one. And for the square matrix, square matrix is matrix with the same number of row and column. For example, the order is 2 by 2 or 3 by 3. For example, this 5883, 2 by 2, the order. Hence, the row have 2 and the column have 3. And for the second example, 0, 3, 4, 3, 7, 1, 4, 0, 5. The order have 3 by 3, which is number of row have 3 and number of column have 3 also. For the fourth types of matrix is identify matrix. Identify matrix is a diagonal matrix with all diagonal element is equals to 1. For example, matrix I is 2 by 2. Matrix I equal to 1, 0, 0, 1. So the order is 2 by 2. And for the 3 by 3 identify matrix is 1, 0, 0, 0, 1, 0, and 0, 0, 1. That's for 3 by 3 order. And for the equal matrices is matrix which have same dimension and their corresponding element. For example, for matrices A, is 2 by 2 order, and for matrices B, the order is 2 by 2 also. Hence, the matrices A for the column 1 and the column 1 row 1 for the matrices A is equal to row 1 and column 1 for matrices B. For like in this diagram, A is equal to E and B is equal to F and C is equal to G and D is equal to H. For the last types of matrix is we have transpose of matrix. Transpose of matrix is a change of corresponding row and column and denoted as AT, which is A transpose. For example, A is matrices A is 1, 1, 0, negative 2, 3, 4, 5. And the order is 3 by 2. And if we transpose it, it changed to 1, negative 2, 4, 0, 3, 5. And the order is 2 by 3. For this mean the row at the matrices A the row change from the row become a column. It's called the transpose of matrix.
Okay, this part we explain about operation of matrices. There are two methods, which is addition and subtraction. Two matrices A and B can be added or subtracted only if they have the same order. The sum of two matrices of different size is undefined. Okay, after that, as like we can see at the diagram, we label as A and B. Row 1, column 1 at A and row 1, column 1 at B equal to A plus E. And row 1, column 2 at A and row 1, column 2 at B equal to B plus F. And row 2, column 1 plus row 2, column 1 at B equal to C plus G. After that, row 2, column 2 at A and row 2, column 2 at B equal to D plus H. Okay, after that, we use the same method for subtraction, but we change the operation to minus. Okay, for example, given matrices A equal 5, 3, 2, 6 and matrices B equal -1, 2, 0, 4. Find A plus B. Okay, the solution is A plus B equal to 5, 3, 2, 6 plus -1, 2, 0, 4. Okay, number after that, row 1 and column 1 from matrices A plus row 1 and column 1 at matrices B. 5 plus -1. And we repeat method for next row and column. Okay, the answer is 4, 5, 2, 0.
Okay, now I will explain about scalar multiplication. Scalar multiplication involves multiplying each element of a matrix by a single scalar. So, to multiply a matrix with a real number, we multiply each element with a number. So, we look at K. K, we have to multiply with A, B, C, and D equal to KA, KB, KC, and KD. So now we look at that next example. So A, 3 have to multiply with 2, 0, and -1. So the answer is 3 multiply with 2 equal to 6. 3 multiply with 0 equals 0. And 3 multiply with -1 is -3. So we look at the B. K multiply with 3, 5, and 1. So the answer is K multiply 3 equal to 3K. K multiply with 5 equal to 5K. And K multiply 1 equal to K. So the last example is C. 1 over 2 multiply with 2, -4, 1, -6, 3, 5, 4, 6, and -2. So we look at that answer. 1 over 2 multiply 2 equal to 1. 1 over 2 multiply -4 equal to -2. 1 over 2 multiply with 1. 1 over, so 1 over 2 equal -6. Sorry, 1 over 2 multiply with -6 equal to -3. 1 over multiply 3 equal to 3 per 2. 1 over 2 multiplied with 5 equal 5 over 2. 1 over 2 multiplied with 4 equal to 2. 1 over 2 multiplied 6 equal 3. And last one, 1 over 2 multiplied negative 2 equal negative 1. So, scalar multiplication, you just to multiply the row and the column.
For my part is I want to explain about determinant 2 by 2 and inverse matrix 2 by 2. What is determinant? Determinant is a scalar value that can be calculated from the element of the matrix. It is denoted by that A or inverse A, where A is the matrix. The determinant is only defined for square matrices, meaning matrices with an equal number of rows and columns. So the process of finding the determinant varies based on the size of the matrix. Example like 2 by 2 or 3 by 3. Example of the that A, you can sorry. The example of the that A is you all can see the diagram, which is A multiplied with D minus C multiplied B. So you can get the value of that A. So for the inverse matrix is for the next is inverse matrix. The inverse matrix given matrix A is equal to A B C D. Then inverse for matrix A is equal to 1 over determinant A, which is that A is AD minus CB, and multiply with a new matrix, which is D change uh, A change to D, and being C change the symbol operation, which is from positive to negative. Okay, the result is 1 over AD minus CB and multiply by D negative C B A. Sorry, the result is 1 over AD minus CB multiplied by D negative C and negative B A. So this is example question for determinant 2 by 2 and example question for inverse matrix 2 by 2. As you can see, the question A is given matrix 1, 2 and 3, 4. So how do we can get a value? The first one is we must do A multiply with D minus C multiply with B. So the equation is 1 multiply 4 minus 3 multiply with 2. So the answer is 4 minus 6, and the final answer is negative 2. This is question A. Or the next is question B. Question B, the same method we can do like question A. The first one is we must multiply the value of A with D and minus the value C multiply with B. So the equation is 2 multiplied with negative 3 minus with negative 3 multiplied with negative 1. So the value is negative 3 minus 3, and the final answer is negative 9. Okay. So the next is example question for inverse matrix 2 by 2. Given matrix A negative 1, negative 2, and negative 3, 4. So the first step is we must do a equation like the diagram, which is a over determinant a multiplied by uh, exchange place with a and c change the symbol, which is from negative to positive and negative to positive. So equation like this: 1 over negative 1 multiplied with 4 minus negative 2 multiplied with 3 divided by 4, 2, negative 3, and negative 1. So the answer is 2, 1, negative 3 over 2, and negative 1 over 2. Oh, that's the final answer. So that's all from us. We hope our explanation can increase our understanding for this, although the explanation in our English is not good. Thank you very well.